Well, for this example, here examples, we first have to take numbers from the fractions and turn them to decimal form. So we have negative 22 over 3. So we really just have to use Mr. or Mrs. calculator right here. Punch it in. You get negative 7.3. But in your answers, it gets the 3 with the dot on top. The dot on top just means the 3 goes on repeatedly. And right here, 13 over 7 is 1.857142. When you punch that in your calculator. Negative 4 and 7 over 8. Okay, you already have 4 point something, negative 4 point something. All you really have to evaluate is 7 divided by 8, what that is, right? 7 divided by 8 is 0.875, and that's what I have, negative 4.875. Right here, 5.0 times 10 to the 5 is 500,000. Okay? So what you have over here, E is 2.85 times 10 to the negative 4. Rule of thumb, whenever you have a positive exponent, okay, 10 to the positive exponent, move that many decimal places to the right, okay? So how I got this answer, I got 5.0, right? 1, 2, 3, 4, 5, okay? Hey, it's the same answer. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So 5, from that decimal place, I move 5 spaces, okay? Now this one right here, you have 2.85 times 10 negative 4, so I would start with 2.85. I go 1, 2, 3, 4, so we get, wherever you stop is the decimal place. Make sure I'm not blocking your way. So you get 0.00285. 0.00285. Hey, you got the right answer. Anyways. So then we talk about the discussion of scientific notation. Okay? Scientific notation. So we have this 373 and we have what? 5 zeros after. We gotta make it so that it has one decimal place. Okay? Well, not one decimal place, but there's only one leading digit in front of that decimal place. And we go 10 to the power of how many spots we move per se. So we go 1, 2, 3, 4, 5, 6, 7. Why do I stop there? Because in that way, I only have 3 in front, okay? Or one number per se. So I don't stop at 37.3, I stop at 3, okay? So remember that, you only want one digit in front of that decimal. So that is 10 to the 7 because I moved 7 times. So over here, if it's opposite, if you see leading zeros, that means your exponent is 10 to some negative number. So you go right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice I didn't stop going extra one. I only want one number in front of that decimal. In this case it was 1. In this case it was 3. Okay? So I moved 11 spots to the right to get 1.54 times 10 to the negative 11 for that answer. Okay, for this one, a little bit tricky. So you got this huge number, 2 with a bunch, this is a 2 by the way, bunch of zeros, and you got 0. Blah 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 7. So the easy way to evaluate this, you could punch in your calculator, but to show you what I mean by scientific notation, this is in reality 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2.0 times 10 to the positive 11. I almost said negative. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 5, 6, 7, 8, 9. Did I copy it down wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. So actually 10 to the negative 9 here. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So minus 9 times 11. So I get 14 times 10 to the 2. Ooh. Okay. 14 times 10 to the 2. I'm going to go one more to the left. If I'm going to be left like that. Let me just take a look right here. Yeah, so when you evaluate this, yeah, 1.4 times 10 to the 2 right here. Punch that in my calculator. Maybe I'm adding some. Oh my gosh. It's 10. Sorry guys, I stopped at the 0 in front of the 7. What am I doing? Okay, that's the negative 10, so that makes more sense. Okay. Made a mistake that you will not make. I put a stop there, you gotta go one more, you gotta put one leading digit. So anyways, when you do that to negative 10, you add those exponents, right? You get 10 to the 1. 7 times 2 is 14. Move 1 back over to the left, that's why it's 1.4 times 10 to the 2.